Let's begin. Today is October 20th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 3, 16, 18, 19, and 20. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A takes a look at our middle digit, the square digit, and compares it to the number 3. So should the value of square be less than 3? Should it be equal to 3? Or should the value of square be greater than 3? Criteria card B takes a look at our 3-digit solution and will let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card C will take a look at our 3 digits, triangle, square, and circle, add them up, and the Turing Machine will let us know if that sum total is an even quantity or an odd quantity. Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare that sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E, again, we'll take a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 3 cases. One where all the 3 digits will have no repetitions, meaning that they're all unique, as in the example 125, or the Turing Machine could let us know that there's a double number or a repeating digit, as in the case of 112, or it could also inform us that it's a triple number. It's a single digit repeated 3 times, as in the example 222. Remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to find out is a little bit about the ratio of even to odds. So let's go ahead and test criteria card B. Okay, so the Turing Machine approves. Notice that in my proposal of 314, I do have 2 odds to a single even. So the Turing Machine confirms that yes, there should be less even than odds. So let's go ahead and type that up in our notes in section B. And again, that's that there are less even than odds. So at a minimum, we know that there should be at least 2 odds and a single even, but it could also be an all odds solution. Well, let's go ahead and test criteria card C. Okay, so the Turing Machine does not approve of the proposal. So again, in criteria card C, we are adding up all the digits. So let's go ahead and do that. So 3 plus 1 is 4, and 4 plus 4 is 8. So my proposal has a sum total of 8, which is an even quantity, but the Turing Machine does not approve that. So what it's letting us know is that the sum of the 3 digits should be odd. So let's go ahead and type that up in our notes. And we'll say that triangle plus square plus circle should be an odd quantity. And so what can we take away from that? Well, again, remember that we have a minimum of 2 odds. So if we consider the case where we do have those 2 odds, that sum total thus far would be even, since an odd plus an odd is an even quantity. But if we want the overall sum to be odd, that means that actually we need all 3 digits to be odd. So let me go ahead and type up an additional note here And I'll just say that it's, let me see, we'll say an all odd solution. Yeah, so the only way for that sum total to be odd is for all three digits to be odd. So let's go ahead and cross out all of the evens in triangle, square, and circle. So, and in anticipation of the next criteria card, I am focusing on criteria card E to see if we're going to have an all distinct solution, or perhaps maybe there could be a pair of digits. Also, notice that since we are dealing with an all odd solution, in looking at criteria card D, the sum of the first two digits, we know we're going to have an even quantity. So, but let's first see, will we have a pair or not? So again, let's test criteria card E. Okay, so the Turing Machine approves of my proposal. Notice that I do have 314, which are all distinct, no repetitions. So let's go ahead and type that up in our notes. And that's in section E. And we'll say that the solution has no repetitions. And of course, what that means is that we'll have uniquely 135 in some order. All those three digits will be used. We just don't know the order. But we have completed our 3 Turing tests for round 1. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test criteria card A, the middle digit, that square digit being compared to 3, nor criteria card D, that is the sum of the first two digits. So notice that even though there is a mentioning of circle in criteria card C, it's not a direct link to the solution. So I feel that somehow that circle digit will be forced into, one of those odd values. So it could be that maybe the sum of the first two digits will be 6 using a 1 and 5, and perhaps it will be forcing that circle digit to be 3. That's one possibility. What else could we have? Yeah, honestly, it could be anything. It could be less than 6, meaning it's 1 and 3, and then forcing circle to be 5, or it could be greater than 6, meaning that it'd be 3, 5, and forcing circle to be 1. So really, we do have our work cut out for us. I'm just hoping that we'll be able to construct a second round proposal that sort of hedges our bets, and that we'll still be able to figure out the solution by the end of the second round. So let's see. If we do choose a sum of 6, what would that tell us? Could we somehow then pivot to the true solution in case it's not equal to 6? Trying to think of Also, I guess, once we know what square is, we should be able to figure out what triangle is. So, obviously choosing a 1 for square would guarantee us less than 6, and that's not true. You could add it to 5 to get us a 6. So what would be a good strategy? If we know square is not, if I choose a 3 for square, would that help us identify what triangle might be based on whatever result we get for criteria card D? Well, we know that if we choose 3 for square, how could we then determine if the sum were 6? Because obviously we're not going to get that. Or if we choose a sum of 6, how do we pivot to being less than or greater than? Yeah, I'm not sure. Let's see. Well, I think, I'm not sure if there is an ideal second round proposal going into round 2. I think I'm just going to choose 1, 3, 5 and see what happens. Okay, so let's first test criteria card D, the sum of the first 2 digits. Okay, so the sum is less than 6. So let's go ahead, since I do add up 1 and 3, that's 4. 4 is less than 6, and the Turing Machine approves of that. So let's go ahead and type that up in our notes in section D. And that is that triangle plus square must be less than 6. Okay, and what can we say about a sum that's less than 6? Well, in order for the sum to be less than 6, actually you can't have either triangle or square be a 5. And that's because if you add up 5 to even the smallest of 1, that's already 6 or greater. So I think that pretty much solidifies circle having to be a 5. So let's go ahead and cross out the 1 and the 3. And of course that's because we are looking for a solution that has no duplicates. So we can say for sure that circle has to be 5. Now, as far as the first 2 digits, I don't think there's a way to deduce. So yeah, we're just going to have to test criteria card A. And so yeah, if I look at my square digit, it is 3. The Turing Machine approves of that. So let's go ahead and type in our notes for section A that yeah, square is equal to 3. And so let's go ahead and cross out the 1 for square. And again, since there are no duplicates, triangle can't be 3 itself. And it looks like, yeah, we have our unique solution of 1, 3, 5. So let's go ahead and type that up. Okay. And let's quickly just review. Yeah, is our middle digit 3? Yes. Are there more odds than evens? Yeah, they're all odd. And we know that because if we add the 3 digits, 1, 3, 5, that gives us a sum total of 9, which is odd. And the sum of the first 2, 1 and 3, That's 4 is less than 6. And again, we have no repetitions. So it looks like a good solution, but let's go verify. And it was 135. Yes, fantastic. And how did we do versus a Turing machine? Well, I do believe there were, 5 criteria cards, and we did exactly 5 Turing tests. That's a great indication that at a minimum, we should have tied and won the game. But let's go verify again. We did do B, C, E in the first round, and then obviously A, D, the remaining 2 in the second round. And C was the only incorrect out of all the Turing tests. So let's type that up, B, C, E. So B was correct, C was incorrect, E was correct, and the remaining 2, A and D, in the second round were both correct. Okay, wow, so we beat the Turing machine by 2 questions. Well, I really do believe that the first round really helped us out because we were able to eliminate all of the evens and only focused on the odds. And of course, we also knew that they were uniquely used. No twins, no pairs of digits. So, well, how did you do? What order and what criteria cards did you use in the first test? And did you notice anything interesting? Add your thoughts to the comment. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, hit subscribe to not miss out on any future videos. Well, until next time, have a great one.